All right, welcome back. This is the second screencast about quantum numbers. In the first screencast, we learned how to link quantum numbers to the periodic table, and we looked at the first two quantum numbers. So now we're going to do the second two and wrap up. And also we're going to, I'll give you a way to take the fourth set of quantum numbers and figure out what element it is. All right, so here was the practice that we left off with. You can see that elements have a first quantum number based on the row, and the second quantum number was based on the section. And I reminded you that in the cases of like iron, you needed to remember to subtract 1, and in the case of TH and DY, you would need to remember to subtract 2 for their row number. Alright, so here's where we left off with our study guide. You have all this information hopefully labeled on a periodic table. The first quantum number, like I said, was row number, and the second quantum number was based on the section. So, the third quantum number is abbreviated with an M. Sometimes it's M sub L, and this is the magnetic quantum number, and this one is describing the orientation in space. So what that means is that in the last the second quantum number, it was describing the shape of the orbital, and these would tell you whether it's pointing up, pointing sideways, pointing towards you. So which direction is that orbital pointing? So what we're going to do, this one is a little tricky, but we are going to count a range, and we're going to use a specific number, and we're going to count the range, and we're going to count it through twice. And the numbers are always going to go negative to positive, and 0 will be included. So the example I've given you here is if you look on your periodic table, boron, carbon, nitrogen, oxygen, fluorine, and neon are all in that one row on the right side of the periodic table. And their third quantum number is -1, 0, +1, -1, 0, +1. So if we look at this set of numbers and we do a little analyzation, we can see that we went from -1 to +1, and then we repeated it, and we have a 0. Okay, so we're going to do a range of a negative number to a positive number, and then we're going to start over again and do negative number to positive number. Well, you might be going, well, how do I know what negative number to start with? I'll show you. Alright, so going back to your periodic table, you have already labeled this information, so let's go ahead and add the third quantum number's information. So that's magnetic Q number, and its orientation and range. Alright, so range is the key word to help you understand what you're doing. I have labeled over here the boron, carbon, nitrogen, that information over here. So you can see that we did -1, 0, 1, -1, 0, 1, just like in the example I showed you. How did we know, first off, how do we know to start with -1? What you do is you look at your second quantum number, and in this case over here, it's a 1. So you're going to go from the negative of this number to the positive of this number, counting all the whole numbers and 0 in between. And in order to find your third quantum number, you need to start at the beginning of your section. So we're going to come over here to the first element in this section, and we're going to go -1, 0, 1, and then we're going to repeat ourselves. -1, 0, 1. Okay? When you do this correctly, it will fit perfectly. If your elements, when you count them, do not fit, then you didn't count them correctly. Okay, so whatever number you land on for your element is your third quantum number. So if we're going in this section here, for instance, we have a second quantum number of 2. So that means that our range number would start with -2. So we would come over here to the beginning of this section, and we'd go -2, -1, 0, 1, 2, and then we'd start over again, -2, -1, 0, 1, 2. So it's going to fit perfectly. Down here in the lower section, we're going to go from -3 to +3, and over here on the right, we're going to have 0 and 0. You can't have any negative numbers, it's just repeating yourself, because remember, we're going to count our range completely twice. Okay, some of my students like to go ahead and number them. I would never bother memorizing it. I would just know that I can look at the second quantum number and count from the negative of that to the positive of that and be able to successfully count it and match it up. Alright, so We're ready to move on to the fourth quantum number. The fourth quantum number is the spin quantum number. And this has a letter S. And this is going to indicate your direction of spin. So your spin is either going to be clockwise or counterclockwise. And that gives you two choices. You can either have a negative 1/2 or a positive 1/2. Okay, that's it. Just those two options. So if you go to the periodic table we've been building, we're going to add our last bit of information. The fourth quantum number is spin quantum number, and that gives us the direction of the spin, and it's either negative or positive. So if you remember me back when we started this in the first screencast, I said that every element has its own unique set of numbers. And so far, when we're counting -1, 0, 1, and we start over again with -1, this -1 grouping and this grouping here have the same quantum number, so we have to add a layer to make them different. So the first time we go through our range, -1, 0, 1, -1, 0, 1, we're going to have a fourth quantum number that's -1/2. And then when we repeat, we're going to start over again, -1, 0, 1. These are all going to have the fourth quantum number of +1/2. So when you go through your range the first time, you have a -1/2 fourth quantum number, and as soon as you start over, you have a +1/2 quantum number. Okay, so the first time through our range, we have -1/2 as the fourth quantum number, and then we repeat ourselves and we get +1/2. So over here in a 0, the first one is -1/2, and the second 0 is +1/2. Okay, one rule that you have to follow when you're doing quantum numbers, and we've understood that from the beginning, it's called Pauli exclusion principle. It states that no two elements may have the same set of quantum numbers, meaning every element is unique. I told you that at the beginning, and you know, you've come to understand that. And that rule is called the Pauli exclusion principle. All right. So if I give you the numbers and I ask you to go backwards and find the symbol, what are you going to do? Well, what I recommend you doing is look at the first two numbers. They're going to tell you both the row and the section. Now, because we're going backwards, remember normally we would subtract 1 or 2 depending on the section, but because we're going backwards, we're going to do the inverse, and so we're going to add. And then you can count over the range number either the first or the second time depending on the 1/2 value. Okay, what does that look like? Well, if you are looking at, let me go back here to the periodic table. If you're looking at a number that says 4, 2, 0, -1/2, if it says 4, 2, we know that the 2 tells us we're in this section, and if we have a 4, we know that we had to add 1, so we're really in the 5th row. Okay, stop and think about that and digest it. I said it's 4, 2, so 2 tells me what section it's in, and because I see that I'm here in row -1, I'd have to add 1, so I'm going to move down to the 5th row. And then I'd count over to 0 either the first time or the second time depending on the 1/2 value. So here are some to practice. You can see that there are 4 that you need to write the quantum numbers for, and then there are 6 where I've given you the quantum numbers and you need to go backwards. So go ahead and work these out. Hit pause while you're working them out, and once you think you have some answers, go ahead and push play to see the answers. So make sure you pause this, take a break, try and solve them, use your periodic table, and then come back and look at the answers. So go ahead and hit pause. Alright, so now you've done your answers and you're ready to check them. So you can see here that there are, hopefully you got the right answers, and if you do not, go back and look at them and see if you can figure out where you may have gone wrong. Again, this is the second part in a 2-part screencast on how to do quantum numbers. Hopefully you've put it all together and you're able to look at a periodic table and have correct answers.